So I have a question for you before we go into the solution of to this problem. What are the variables that follow symmetric nature in a projectile motion, and how is that symmetry observed? Okay. Now, given to us in the question that a ball is thrown vertically up with a certain velocity, VA, it reaches the maximum height h. So this complete height here is h, right? Find the ratio of the. Oh, okay. I think that is. Oh, I have not written in all the solutions. Okay, so it basically. Okay, let me just get the correct question. So actually, the questions ask find the ratio of the times in which it is at the same height while going up and down, respectively. Same height. What? Same height. H by 3. So while going up, it reaches a point C, h by 3, say at some point T1. And while coming down, which is, so this is motion along AB, and then we have motion along BC coming downwards. It crosses the same point, which is C at a height at h by 3, but this time at time T2. What is the ratio of these times, T1 and T2? See, in my personal opinion, the primary objective of this question is definitely to evaluate your knowledge on the quadratic nature of this of the displacement time relationship. Let me just write it down that as well. The quadratic nature of the displacement time relation, which is S is equal to ut plus half at square. Yes, that is the primary thing. But underlying that, a couple of things that we should that is a potential source of question for the coming JEE mains, for that matter, any exams related to this chapter, has to be considered, which is about the symmetric nature. Okay. So first and foremost, let's try to solve this question, and then we'll come back to the topic of symmetric nature. So for this motion along AB through C, where C is at a height, h by 3. Okay, well, we don't need that point here, so that's why I'm not marked it. Now, along AB, the distance between A and B is, h. It is projected from A, velocity is VA, it reaches its maximum height at B, and the velocity there is 0. But it is not explicitly stated in the question. Then how do we assume that it is 0? It is 0 because, why? It is 0 because at the maximum height, can I complete the rest? At the maximum height, exactly, the ball will be momentarily at rest. And what happens after this rest? It reverses its direction of velocity and it comes down. Something that we have been discussing on and on for the last 3 to 4 questions, right? Okay. Now for this motion from A to B through C, what is V is equal to U plus AT? What is V? Final velocity, which is velocity at the final point, which is B, VB. U is initial velocity at the initial point, A, VA. A is minus G. Why is it minus G? Because acceleration due to gravity is acting downwards, and this acceleration due to gravity is acting against the initial direction of velocity. Therefore, it will cause a retarding effect. And since it is causing a retarding effect, G would be negative. VB is 0, therefore V is equal to minus GTA, and time of A, by which I mean time of ascent, the maximum height. So time of ascent is VA upon G. VA upon G. For the same path, if we apply V square minus U square is equal to 2AS, VB is 0, VA is VA, A is minus G, we have VA is equal to root of 2GH. Of course, negative over negative is 1, right? So VA is equal to root of 2GH. Hope that makes sense. Right? Now we will discuss along the path h by 3. So we don't need this much here. We need only the direction, the motion along A to C. Maybe I should write it down. So from motion along the path A to C, motion along the path A to C, what is S is equal to ut plus half at square. What is t square? Time to reach AC, not time of ascent, time to reach AC. This is where most of us make a mistake while solving this question. And I think understanding the minute error here is very significant. So, what is t here? T is the time to complete the motion. How is the motion? It is starting from A to C. So, time taken to cover AC is t here. What is displacement? It is h by 3. U is initial velocity VA. So, VA into TAC plus half into acceleration is minus G TAC square. So, h of t is equal to what is VA? We just found it out to be root of 2GH. Root of 2GH, which gives us VA is root of 2GH time AC minus half G TAC square. What is special about this equation? What is special about this equation? Exactly, this is an equation which is quadratic in nature. And quadratic in which variable? A? No. VA? No. G? No. It is quadratic in TAC. It is quadratic equation in TAC. What does that further imply? It implies that this equation, h by 3 is equal to root of 2gh TAC minus half GTAC square, can be written as, which otherwise can be written as 0 is equal to half GTAC square minus root of 2gh TAC plus h by 3, can be compared with the equation ax square plus bx plus c is equal to 0. And what do we get out of that? What we get is a is equal to half g, b is equal to minus root of 2gh, and c is equal to h by 3. Okay, so we get these values. A is equal to gt square by 2, b is equal to minus root of 2gh, c is equal to h by 3. And if we have these, we have x is equal to minus b plus or minus root of b square minus 4ac by, of course, by 2a. And what is x1? X1 is equal to minus b plus or minus root of b square minus 4ac by 2a. And x2 will be minus b minus root of b square minus 4. Oh, did I say plus or minus? Sorry, plus. And minus 4ac by 2a. Now, yes, we do have two values of x. But what is this equation quadratic in? This equation is quadratic in TAC, which is time to reach AC. Therefore, what we get is not x1 and x2, rather it is TAC1 and TAC2. Which means if we solve this equation, what we get is two instances of time at which the ball is at the same position in the vertical projectile motion. Okay. So what is TAC? Will be equal to root of minus b minus root 2gh plus root 2gh plus or minus root of b square root of 2gh the whole square, which is 2gh, minus 4ac, 4 over 2 is 2gh by 3, the whole upon g, by 2a. 2a is 2g by 2. Now, this actually gives us two values. Minus b plus root of b square minus 4ac and minus b minus root of b square minus 4ac. 2 times 3 is 6, 6 minus 4 is 2, 2 times 3 is 6, 6 minus 2 is 6 minus 4 is 2, plus minus. So T1 by T2 would be root of 2gh plus root of 2gh times root 2 by root 3. And how did we come to that? Okay, now guys, that will be really basics of algebraic, right? Let's not spend time there. Okay, so Wait. But we need to write. That might be confusing, right? Did I make a mistake here? No, I think I have made a mistake here. Okay, guys, give me a second to rectify this. Sorry for the delay. So, the mistake was not in the upcoming part. It was already done in this section here, where I wrote. Extremely sorry for the delay. So what happened here was I made a minor mistake while rewriting this step here. So this would be 3 into 2, 6, 6 minus 2, 4. Instead, I wrote that as 2. That's where the mistake came up. Okay, anyway. So we have 3 into 2, 6 GH minus 2 GH is 4 GH by 3 plus and minus. So we have plus root of 4 GH by 3 minus root of 4 GH by 3. And when we take the ratio T1 by T2, what happens? The G by G is 1. And we're left with root of T2GH plus root of 2GH root 2 by 3 minus root of 2GH root 2 by 3. I divide this complete expression by root of 2GH root of 2GH. Now, how did this root 2 come up here? Very simple. Because root of 4GH can be written as root 2GH into 2, which can be split as root of 2GH into root of 2. Root of 2GH into root of 2. Then I divide this complete expression by root of 2GH, which gives me by 1, 1, 1, and 1, which is 1 plus root 2 by root 3 by 1 minus root 2 by root 3, which is further equal to root 3 plus root 2 by root 3 minus root 2. Okay, so this is what we have to say regarding the question here. Now, so it's a very humble request that you please write down these steps, write down these solutions along with me, and please don't skip up. Please, guys, very humble request. Please don't skip up the coming solutions. So I have close to 5 to 6 additional parts, which I consider, which in my opinion is the significant underlying concept of this question. And when there is a concept which is underlying for a given problem in a previous year question, what does that imply? Exactly, it implies a potential question in the coming JEE mains. So please, I request you, do not skip the coming solutions. We will try to do the same question using v is equal to u plus at and v square minus u square is equal to 2as alone by splitting the motion into two halves. Something which is very time consuming for the point of view from the point of view of JEE mains, but is very conceptual. It will show you it will give you further insights on selecting the direction of velocity and acceleration during the complete motion. And I don't want to solve this question using work energy, power, and mechanical energy conservation. In fact, you can try doing that, and you should probably get the same answer. In fact, you should be getting the same answer. So go through those two approaches. If you have any confusion, if you have any queries regarding that, feel free to write to me, and we'll discuss on that as well. But as of now, I'm not going to dive into work energy, power, and conservation of mechanical energy and work energy theorem. Okay, but we will have to go through the motion in two halves in detail and about the symmetry of it. Okay, right. So now let us try to do the same question by considering the motion as two halves, one going up and the other going down. So yes, this is what I want you to write down. Now what we'll do is we will divide this motion, which means motion of the ball thrown up with velocity VA into two halves, thrown from A, covering the points A, B, and C in order from A, where B is at a height h by 3 from the ground. And the second motion, the second half of the motion, would be considered to be one such that it is dropped from C, moving downwards, covering the points C, B, and A in order, where B is at a height h by 3 from the ground. Thrown up with A, B, and C, where actually I should have written it's A, B, and C, like this. Sorry. Okay. And it is really important to understand the symmetry that we come across here. Okay. Right. So upward motion from A to B, then C. At C, the object is momentarily at rest, which means velocity at C is equal to 0, which means velocity at C is equal to 0. And then the downward motion to be considered as 1 being dropped. Why? Because at the maximum point, velocity at C is equal to 0 and it moves down and reaches A. And in both cases, it is crossing the point B, which is at a height h by 3 from the ground. Now this motion, the path is really important. It goes like this, then comes like this, right? So it is coming to this point B like this, 1 and 2. Okay. So the time taken to cover A to B, A to C is time of ascent TA. Now, for the motion along AB, now see guys, this is the calculations here are very tricky. Trust me, it took me really long time to write it in an organized way, and to make sure that the idea is as clear as possible. So the number of steps would definitely be more here. Yes, I do understand that's the case in almost every question. Apologies again. So what I would say is, please write this along with me, right? Because the intention here is not just to solve the question the quickest way, but it's also to understand every possible concept, underlying concept in the given problem, which could be a potential question in the coming JEE Mains, if that makes sense. Right? So please, it's a humble request that you write these things along with me. So for the motion along AB, the displacement are SA and SB respectively. Velocity is VB, it's VA and VB respectively. The time is TA and TB. Velocity is upwards. Acceleration due to gravity is acting downwards. Displacement is from the initial position to the final position acting upwards. So what does this imply? This implies that displacement S is positive, velocity V is positive, and acceleration A is minus G, negative, acting downwards. So V is equal to U plus AT. V is the final velocity at the final point, which is at B. Therefore, is VB. U is velocity at the initial point. At A is VA plus A is, my bad, this is, plus A is minus G. T is time to reach B. How? Time to reach B while it was moving upwards. Okay. So VB is VA plus y minus A to G TB. VB is VA minus GTB. Therefore, minus GTB while going upwards is VB minus VA. Yes, nothing conclusive so far. Now let's see what's the case with the same motion along AB. But this time using equation V square minus U square is 2AS. Yes, we're not using the equation S is equal to UT plus half AT square. Instead, we are using V is equal to U plus AT and V square minus U square is 2AS. Multiple ways of looking at the same problem. What is V? Final velocity VB. U initial velocity VA. A is again minus G. VB square minus VA square is 2 into minus. What is S? S is displacement, which is final position minus initial position, which is SB minus SA. And what is SB minus SA? It is this distance or this height AB, which is h by 3. So we have VB squared minus VA squared is minus 2G into h by 3. But what is h? Okay, to understand h, we need to come to the maximum height AC. So when the object is projected from A, it reaches the maximum height where it is momentarily at rest. And since it is momentarily at rest, at that point, the corresponding velocity Vc would be equal to 0. Applying V squared minus U squared is 2as. Vc is 0, which means we have 0 squared minus U is Va minus G, and this time S is, what is S? S is, this S is actually equal to SC minus SA, which is equal to this distance, equal to this height, which is the complete height, H. So we get VA square is equal to 2GH, or H is equal to V square by 2G. What do we do with this? We bring this H is equal to VA squared by 2G. So G over G is 1. This becomes minus 2VA squared by 3. Right? Oh, sorry, minus VA squared by 3. Right? So 2 by 2 is 1. G by G is 1. So VB square minus VA square is minus VA square by 3 and not plus VA square by 3. It's one of the most common mistakes, one of the mistakes that we see commonly in almost every wrong answer that has been done. Okay. So what would be VB here? VB will be equal to VA square minus VA square by 3. Now, if you're not writing this along with me, I mean, if you don't have this data in a paper along with you, I'm pretty sure you would have already confused yourself a lot, because it won't make sense, and it is not practical to include all the data in one board here, because it will really clog the view. So please make sure, it's a very humble request, that you write down things along with me and then try to interpret this. Okay, right. So VB square is VA square minus VA square by 3. What is VA square minus VA square by 3? It is 2 VA square by 3. Now, taking root on both sides, root of VB square is equal to root of 2 by 3 VA square. What we get is VB is equal to 2 by 3 VA. Okay. Now, what do we do with this 2 by 3 VA? That's where the important point comes in. Why? Because we earlier had an equation which says what? Which says VB minus VA is equal to minus G into TB while going up. What can we plug in? We can plug in the value of VB as root 2 by root 3 VA. Minus VA is equal to minus GTB going upwards. Yes, I think now things are becoming clear to you, right? Why? Because we are close to find out T to reach B, the motion upwards. I would actually suggest that you can pause the solution here, right? Stop watching this. Try to do the rest on your own. Consider the reverse motion, that is from C to A. Apply the same conditions. V is equal to U plus AT. V squared minus U squared is equal to AS. Then try to find out the same time coming downwards on your own. If you don't get the answer, then maybe you can come back and watch the rest. Does that make sense? Please do consider that. Okay? Right. So root of 2 by 3 VA minus VA is, I'm just transposing this minus G. Wait, did I skip a step here? Oh, I did skip a step here. Sorry, my bad. This should be GTB. All what I've done is I have removed this negative here. So that becomes minus root 3A. Yeah. So VA minus root 3 by VA is root 3 VA minus root 2 VA by root 3. And what I have done is I have taken VA as common from these two terms, and therefore this becomes VA times root 3 minus root 2 by root 3. is equal to G times TB, is equal to G times TB. And therefore, VA by G into root 3 minus root 2 by root 3 is TB going upwards. What is B? B is the position h by 3. So it is a time to reach the h by 3 height while going upwards, which we will assume it for our ease of calculation as T1. Does that make sense? So far, this conversion is really important. To understand this is the key here. Okay. And how will you understand this? Only if you have the diagram corresponding to the situation. So we have A here, B here. So time to reach P is actually the time to reach the corresponding height, which is the height h by 3. Okay. Now coming to the reverse motion, what happens here? The direction of velocity is reversed. Direction of velocity is reversed, which means velocity is negative. If you're back now, right? If you're back into the solution after trying to do that on your own, and I presume that you got it wrong, which is in fact the reason why you're back here, then first of all, congrats that you have tried it, tried doing the rest on your own. And please do acknowledge that it is very common to make mistakes. Trust me, when I was doing this problem for the first time, it took me around 7 to 8 attempts to make this part clear. So if you, well, of course, I'm not trying to put a benchmark standard of mine here and then comparing yours with that, because my experience in solving, my expertise in solving the question comes from years of experience in teaching and not at your level of solving the questions. So please don't make please don't get offended by the statement here. I was just trying to tell you that even after teaching this chapter for many years, I still struggle to do this question with proper amount of detailing. So if you have made this question and made an error by solving this question, it is very normal to be. Okay, to make such a mistake. There is nothing wrong in doing that. To make mistake is human, and making mistakes in these kind of high level questions, it is very obvious thing. Don't demoralize yourself. Don't don't get your morale down. Don't just keep on telling to yourself that, oh, I made this question wrong even after watching the solution. No, it is very human to make these kind of mistakes, especially when we do questions which are based on directions of motion. It becomes really tricky. Okay, so kudos that you tried to do that on your own. You have made a mistake, no problem. We'll go through the solution one more time. Things will become really clear to you, and then you will not be strong in the question. When will you become strong in the question? When your concepts are really, strengthened. How? When you do this question over and over again. When you do the same question, not by watching the solution, but by looking at your solution that you have written down while watching this, and then speed comes naturally to you. Okay, right. So acceleration due to gravity is again acting downwards, which is negative. Displacement is, how's displacement? Direction of displacement. Yes, of course it is. From the initial position to the final position, which again is acting downwards, would be negative. So S is negative, V is negative, G as well. Okay. Now to understand this is very important. So just to make sure that you get the things very clear, while the motion of the body is coming downwards, it first reaches a point P where the corresponding displacement, time and velocity are SP, TB and VB respectively from SC, TC and VC. Okay, and eventually it comes to rest. At this position, the displacement is H, and the corresponding position, the displacement is what? It is H by 3. Okay. Now, the first equation, V is equal to U plus AT. What is VB? It is VC plus minus G into TB. Exactly. This is where the mistake comes in, right? Is there something wrong in this equation? You pointed it out correctly. This is wrong. Why? Because velocity is acting downwards. It is minus VB. Initial velocity as well. It is acting downwards. It should be minus VC, which doesn't matter here. Why? Because it is dropped from rest. Okay. So minus VB is minus GT in TB. So minus VB is GT in TB. Therefore, TB is minus VB by minus G. Therefore, you get time as positive, which you might have got as negative. And then you are like, how can time be negative? Time was not negative. It just gives you it points out the error in choosing the reference direction. Okay. So what is TB to reach while coming downwards? Time taken to reach B while coming downwards is VB by G. Now you might be wondering, earlier we had two terms in the equation. Now we have only one VB by G. Then how can we come to the previous answer, which is actually root 3 minus root 2 by root 3 plus root 2? We just have one term here. Now that is where the question becomes really interesting. It is this part where where analyzing the motion becomes interesting. Okay. So when we consider the same motion from v square minus u from C to B by the equation v square minus u square is 2as, where again minus VB, G is minus G. So minus VB square. Okay. Now this is tricky. Why? Because v square is minus VB the whole square. What is u square? It is minus VC the whole square, right? Which is minus VB the whole square is VB square minus VC the whole square is VC square. So VB square minus VC square is equal to 2 into minus G into S is 2h by 3. Oh, I'm sorry. It should be h by 3, right? Is it? No, guys, no. It is 2h by 3. And why is it so? Let's see. Concept. This is where breaking down these concepts becomes really important. So this much height, what you have here is h, right? This complete height here is, let me just write it down as well. So this complete height here is h. And B is at a height h by 3. But from where? B is at a height h by 3 from the ground and not from the maximum height. So when B is at a, yes, I do understand that this is where most of us have gone wrong, right? Pretty obvious. I think I got myself corrected here in my 4th or 5th attempt. And even then I had to make mistakes in the coming calculations. So that's more than okay to be, okay? Just don't be disappointed by that. It's pretty common to do so. Okay, now, so B is at a height h by 3 from the ground, which means it will be at a height of this much, which is actually h minus h by 3, which is 2h by 3. So VB square is VC square minus VC square, which is 0, equal to 2 into minus 2gh by 3. So VB square is 2 into minus g 2h by 3. Wait. Okay. Now comes the, look at this. I made a mistake again. So displacement, I made another mistake here. Can you point out what that is? Take a minute. I've made another mistake here in setting up this equation. Why? Because if I write this, I will get VB square is minus 4gh by 3, and you cannot find the square of a negative number unless we're talking about complex numbers and JEE maths. Velocity can't be complex. What is that? I'm pretty sure some of us might have understood the correct point here, which is, since displacement is acting downwards, displacement should also be negative. So this should be minus 2h by 3. And therefore, negative times negative is positive, which gives us VB square is positive 4gh by 3, or otherwise VB is equal to root of 4g by 3. What is h? We already have found it as v square by 2g. And therefore VB square is root of 4g, root of 4, which is 2, g by g is 1, 4 by 2 is 1. So, 4 by 2 is 2. Okay, I'm not taking the root here. So VB square, now taking root on both sides, what we get is root of VB square is VB, root of 2 by 3. Wait, what am I doing here? Oh, that was the same step that I've repeated again. Sorry, my bad. Now taking root of both sides, what we get is root of 2 by root of 3 into VA. So velocity at B coming downwards is root 2 by root 3 VA. Are we done? No, because the point is not to find out the velocity, it is rather to find out the time at the corresponding velocity, right? That is where we have this equation. VB by G is equal to TB. What is VB? We just found out to be root of 2 by root of 3 VA, but where is, are we missing something here? Something that we really need to understand here is this is where most of us make a very common mistake. VA square is positive. Yes. But VA is negative. Why? Because velocity is acting downwards. Therefore, well, see, from here, you can actually directly go for this positive value. I do understand that. But if you haven't considered this negative here, then VB should be taken as negative here. Listen to this very carefully, okay? Give you maximum focus. If I wouldn't have considered this negative by negative as positive here, I would have ended up in a different zone, right? And then I'll feel that time is, if I made a mistake, then I will get time as negative. But why am I getting that mistake? Because I'm substituting VB as positive direction here, which is not the case. Why? Because velocity is acting downwards and therefore it should be negative. And then we get negative by negative as positive. Okay, right. So, yes, time to reach B while coming downwards is root of 2 by root of 3 VA by G. Now, we didn't get anything of the form root 3 minus root 2 by root 3 plus root 2 again. We are stuck. Are we? Well, if not, we do it properly. So, very important to understand that time to reach B while coming downwards, or maybe time to reach B when dropped from C, is root 2 VA by root 3G. Let us visualize this. Okay, let us visualize this. Time to reach B while coming downwards is equal to time to reach B from C is equal to time to reach B from C. Time to reach B from C. But what is TA, time of ascent? Time of ascent is time taken to reach C from A. So this is time to reach C, and then, so this much portion here is time to reach ascent, and then this much portion here is time to reach C from B, time to reach B from C. And at this instant of time, we are at this position, we have two instances of time. Okay. Well, actually, I'm also exhausted. Maybe that's why I'm not able to explain this well. Please go out, watch it one more time and talk to yourself. And I'm pretty sure that if you have written this down along with me, and if you talk that to yourself, things will become really clear to you. Okay. Now, if I were to write this in equation, time to reach h by 3 height, which is this, while coming downwards, is actually equal to time to reach the apex position or time of ascent plus time to reach the same position at P from C, time to reach B from C. What is time to reach the apex position? It is VA by G. What is TC by B? It is root of 2 VA by root of 3 g, right? Now I can say that time to reach h by 3 downwards, if I take va common from here, is 1 by g plus root 2 by root 3 g. Sorry, I missed that. Now, multiplying root 3 here in the numerator and in the denominator, what I get is VA into root 3 plus root 2 by root 3g is time to reach h by 3 while coming downwards. So we have two values. Which are they? Time to reach h by 3 upwards is VA into root 3 minus root 2 by root 3g. Time to reach h by 3 downwards is VA into root of root 3 plus root 2 by root 3g. Okay? Now, taking the ratios, what we get is root 3 minus root 2 by root 3 plus root. Wait, what is an arrow mistake here? Yeah, this is not upwards, this is downwards. Yes, I do understand, guys. It's a very lengthy explanation because I just wanted to make sure that you don't make any mistake in any of the formulas, in any of the sign conventions that we use. Okay, are we done? Yes. So far, so good with the solution. Now we need to spend some more time to understand the symmetric nature of this. Please don't, it's a very humble request, please don't skip the solution without writing down and without following what has been discussed with respect to symmetry in velocity, in time, and in displacement. So very, very important concepts. In fact, they are very crucial. That I do expect a very potential. I would say that this is a very potential area for a upcoming question in the JEE Mains. Okay. So let's first discuss about the displacement symmetry. Now, when we divide the motion into two halves along AC, which is moving from A to C upwards, and then along CA, which is moving from C to A downwards. And then we apply the same equation, ST is equal to UT plus half AT square in both these. And then we try to find out what the symmetry of displacements look like. Okay. So first things first, V is equal to U plus AT. And for the motion along AC, which means for this motion here, right, from A to C, VC is equal to VA plus acceleration along AC to time to reach AC, or time to reach C from A. What is acceleration along AC? So an object is thrown upwards, means velocity is positive. Acceleration due to gravity will always act downwards, so it is negative g. Displacement is acting upwards, so S is positive, right? So we have velocity is positive, and acceleration here is negative g. So time to reach the apex position is VA by g, something that we have derived many times. Now, why do we need this? What is the displacement as a function of time for the motion along AC? Displacement is, as a function of time, is UT plus half AT square. Displacement at TA minus delta T. Now, what is that? So, if we consider the motion from A to C, which means corresponding to time t is equal to 0 to time t is equal to TA along time is equal to t1. T is equal to 0, the ball is projected. T is equal to t1, the ball is at a height p. T is equal to ta, the ball is at a height, the maximum height c. Okay? If this is the case, then 0 I mean, time t is equal to 0 to t is equal to t1 to t is equal to ta, right? So 0 to, so this much time, this complete time is ta. To reach b is t1. So if you consider this portion after t1 to ta as delta t, then we can say that t1 is complete ta minus this delta t. Hope that makes sense. Time to reach 1, the position 1, is the complete time taken to ascend minus this delta t. Okay, if that is clear, then we can say that time to displacement in that corresponding time, ta minus delta t, is u into ta minus delta t plus half a into ta minus delta t the whole square. U into ta is uta minus u delta t plus half a is minus g. Ta minus delta t the whole square is ta square plus delta t square minus 2ta delta t. Multiplying this negative g within the brackets, minus gta squared by 2 minus into plus minus g delta t squared by 2 minus into minus plus gta delta t. Oh wait, I missed something here, which is by 2, and since there is another 2 here, 2 by 2 is 1. Okay, so we don't need that one. Okay, now, so what do we do with this expression? This is a bit algebraically complex. So minus, okay, so minus gta squared by 2 minus g delta t squared by 2 plus gta delta t. What is gta? See, we know that va by g is equal to t. So what is va? Va will be equal to gta, right? Plugging that equation here, what is gta? Gta will be equal to va. Oh, I'm really sorry. I forgot to mention this expression here, that va is assumed to be u for ease of calculation. Okay, so gta can be replaced by u. So we have u delta t plus u delta t and minus u delta t, which means these two terms cancel off. The remaining terms are uta minus half gta squared by 2 minus g delta t squared by 2. Now there is something very peculiar with this equation. What is that? It is of the form ut minus half gt squared. And what is ta? Ta is time of ascent. What is time of ascent? It is the time taken to reach the maximum position, which is h. So this expression is s is equal to ut minus half at squared, which is equal to h max or h minus g into delta t squared by 2. What is this? This is the displacement in time ta minus delta t. Are we done? No. Similarly, if you work out ta plus delta t, so this much is ta, this portion here is delta t. So to come here, we have ta minus delta t. When the motion continues, it travels this much down further. That will be ta plus delta t. You can go through the same derivation here, but substitute using ta plus delta t. Okay, I'm not doing that here because that will be just a mere replication of what we're doing so far. But I would suggest, I request you that you please go through that derivation as well. Once we have that, we can find out that sta delta plus delta t will give you the same value, h max minus d delta t square by 2, which means sta plus delta t is equal to s Okay, sorry, my bad. STA minus delta T, right? STA minus delta T is equal to STA plus delta T, which means the corresponding displacements are equal when the time is TA minus delta T and TA plus delta T. So, displacement from the starting point at a given time on the way up matches the displacement at the corresponding time from the end of the motion on the way down. But the velocity direction is opposite. We will discuss that in detail later. If u is 20 meter per second, g is 10 meter per second, at t is equal to 1 upwards and t is equal to 3 downwards, same displacement 15 meters is observed with, of course, opposite velocity. Okay. To understand the graphical representation of this, at time, okay, let us take a different example. So we have at time is equal to 1 second and at time is equal to 3 seconds, the displacement is same, which is 15 meters. At time, let me take a symmetric value, which otherwise would be, okay. Do we have any other value that is correctly on the graph here? Okay, so at this point, so maybe at time, at 3.25 and 0.75, the displacement is corresponding to 12.5 meters. So yes, displacement is symmetric from the point of launch to, sorry, from the time of launch to time of ascent, and then from time of ascent to the final point, the ground launching point again. Okay, a little bit complex, I do understand. Go through, please go through the explanation one more time. And well, I just don't want to repeat this explanation again, because something that we've been that we will discuss many more times in the coming explanations. But apologies that I have not made the explanation. I could have made it better. I do understand. I do realize that. Sorry. Maybe I'll try to match up in the coming explanations. Okay. Now let's see what happens in the velocity at equal points. Now let's try to understand the symmetry between, or the symmetry of velocities in a projectile motion. What are the paths that we are considering? Motion along AB and then to C. So motion along A to C through B. Then we have the corresponding motion downwards, which is motion along CA through B. And the body is in the same position B along the upward motion and the downward motion at two different times T1 and T2. We are trying to understand the velocities at T1 and T2. To express T1, what we'll do is, from A to C, the total time taken is T, which is time taken to reach the apex point TA. The time taken from B to C, is delta T. If we consider time taken from A to B as T1, what is this T1 equal to? TA minus delta T. So T1 would be equal to TA minus delta T. Correspondingly, when the object is coming downwards, it will have delta T for some time, right? And it will cover the equal time interval downwards, which is, which will cover the same distance delta T. Now, delta T from A to C, it has covered the time TA. From C to B, it has covered the time delta T. So from A to B, it will be sum of time from A to C plus A to B. So T of AB will be equal to T of AC plus T of CB. What is T of AB? It is TA. What is T of CB? It is delta T. So we have 2 times Ta minus delta t and Ta plus delta t. Does that make sense? Okay. So we'll find out the velocities at Ta minus delta t and Ta plus delta t by the equation v is equal to u plus at. What is v? The final velocity at t minus delta t, t plus delta t. U plus at. U is the velocity with which is launched. A is minus g. So A into Ta minus delta t is Ata minus A delta t. A is minus gta plus g delta t. Ata plus A delta t. A is minus gta minus g delta t. U plus minus delta t is U minus delta t or U minus gta. U plus minus gta is again U minus gta. So the only difference what we have here is plus gt and minus gt. What is U minus gta? See, for the complete motion along AC, what is V is equal to? V is equal to U plus AT. What is V? V is the velocity at C. What is U? Is the velocity at A. Plus what is A? A is minus G. What is T? T is the time of ascent. Why? Because it is the maximum position. At the maximum position, velocity at C is equal to 0. Why? Because it is momentarily at rest. Therefore, VC is equal to 0, which gives us minus VA is equal to minus GTA, or VA we assumed here as U. So U is equal to GTA. So what is U? U is GTA. If we plug in that value here, U is equal to GTA. U here is equal to GTA, right? So GTA minus GTA is equal to 0. GTA minus GTA here is equal to 0, which means we have V at Ta minus delta T is equal to plus G delta T, and VTA plus delta T is equal to minus G delta T. What is the inference? The inference is VTA minus delta T is equal to minus VTA plus delta T. That is, velocities are of the same magnitude, but the opposite direction. Okay. Let us also look at the graph here. So symmetry in velocity means magnitudes are equal at corresponding times, but the directions flip. Minus flip. If it leaves our hand at 20 meter per second upwards, it will return to our hand at the same speed, same magnitude, 20 meter per second, but direction flipped, positive 20, it comes to our hand at negative 20. The speed is the same, and therefore energy is conserved, but the sign changes, which means the direction of motion is reversed. If we were to understand the graph here, so we have velocity in y-axis, time in x-axis, velocity plotted from negative 20 to positive 20. So at time 5 seconds and at time 2.5 seconds, we have the corresponding velocities as, okay, wait a second. Yeah, that would be a better way of comparing, right? So at time is equal to 1.5 seconds, the velocity corresponds to plus 5. At 2.5 seconds, the velocity corresponds to negative 5. So this is what we mean by symmetry of velocity. Okay. So yes, so these are the things that are that I was mentioning about could is a is the underlying concept behind this question. So could be a potential case of uh, upcoming JEE Mains, right? Now, are we done? No, we are not. Why? Because we now will understand the symmetry of time, which is the foundation for symmetry of velocity and velocity and displacement. In fact, I should have taken you through time first and then velocity and displacement, but I just took you the other way around. I'm really sorry, because the reason why I did was I wanted you to think, why did I take that region as time of ascent, and then am I implying that it is half, equally half in both the sides? Because I've been repeatedly telling this in throughout the solution, this particular question, that we are dividing this motion into two halves, the first half and the second half. But then what is the proof that these two motions are actually the half of each other? Right? That is what we see in the next part. So we'll solve this question now, not based on h by 3, but for any height h, which means the vertical displacement that we consider here would be y equal to s. Oh, that would be a bit confusing. The vertical displacement would be s is equal to ut plus half at square, where the maximum vertical displacement is s equal to lambda h. What does that mean? When lambda is equal to 0, what is s equal to? Corresponding s is equal to 0, which means it is at ground. When lambda is equal to 1, s is equal to s is equal to 1 into h, which is equal to h, which means lambda is equal to 1 gives the topmost position or the top point. Does that make sense? What is lambda? And the value of lambda will be 0 less than or equal to lambda less than or equal to 1. Okay? Now, motion along A to C through B, motion along C to A through B. A to C through B, C to A through B. B is at a point such that it is at a height h by 3 from the ground, which is seen in the motion at two different times, t1 and t2. Now we have already derived that the maximum height h is equal to u square by 2g, and that the vertical displacement s is assumed here to be a multiple of lambda times h. Plugging these two into the equation here, which is v square is equal to u square plus 2as, where a is minus g. What is s? S is lambda h. What is h? H is u square by 2g. So what we get here is v square is equal to u square minus 2g into lambda. H is u square by 2g. 2 by 2 is 1. G by g is 1. So what we have is v square is equal to u square minus lambda u square, right? U square minus lambda u square. Taking u square as common, what we get is u square into 1 minus lambda. U square into 1 minus lambda. Okay? This gives us two velocities. Why? So if v square is equal to u square into 1 minus lambda, what we get is v is either plus u into 1 minus lambda, which is the velocity as going upwards, and we get v is equal to minus u into 1 minus lambda, which is velocity that is coming downwards. Or in other words, this is velocity at time t to reach b from A, and this is velocity at time to reach B coming down from C. Going upwards, coming downwards. Okay? Now, if velocity upward is v is equal to plus u into 1 minus lambda, what is v is equal to? U plus at. What is v at t1 is equal to? U plus a into t1. What is a? Minus g. What is v at t1? Is u into 1 minus lambda. Is u into 1 minus lambda. Made a small mistake here, sorry. So this would actually have u into 1 minus lambda minus u the whole by g is equal to the whole by minus g is equal to t1 while going upwards, and we have u into 1 plus root of 1 minus lambda minus u the whole by g while coming downwards. So we found out the expression for two time instances, t1 and t2. which corresponds to the same height h by 3 from ground for any fraction of height lambda h. Hope that makes sense. Okay, now let's move on to the is that the next question, the one with the ball being juggled, with the number of balls being juggled?